What if we could harness the sun's energy on a scale beyond our wildest imagination? For centuries, humanity has looked up at the sky, marveling at the sheer brilliance and power of our star. The sun is the engine of life on Earth, fueling everything from the smallest plant to the most advanced technologies. But what if we could go further, much further, than simply basking in its warmth? Imagine a structure so audacious, so ambitious that it could capture nearly every photon our star emits. Not just a few solar panels on rooftops or even sprawling solar farms, but a colossal network of technology encircling the sun itself, designed to intercept and utilize the vast majority of its energy output. This is the captivating idea behind the Dyson sphere, a hypothetical megastructure that has enthralled scientists, science fiction authors, and dreamers alike. The concept has inspired countless works of fiction and scientific debate, pushing the boundaries of what we consider possible for an advanced civilization. The sun bathes our planet in energy, but even with vast solar farms, we capture just a tiny fraction. In fact, less than 1/1,000,000th of the sun's total energy ever reaches Earth, and of that, only a sliver is harnessed for human use. The rest radiates out into the void, untapped and unused. A Dyson sphere proposes something far grander, a sphere, or a system of components, completely enveloping the sun to capture its full output. This could take the form of a solid shell, a swarm of satellites, or a vast network of interconnected structures, all working together to harvest energy on a scale never before imagined. The implications of such a feat are staggering. It would represent a technological leap so profound that it would redefine what it means to be a civilization. We would no longer be limited by the resources of a single planet, but would instead tap directly into the power of a star. With access to the sun's total energy output, currently an unfathomable 384.6 septillion watts per second, humanity would have effectively limitless power. To put that in perspective, that's enough energy to power every city, every machine, and every dream we could possibly imagine, for millions of years to come. The very limitations we face today, energy scarcity, climate change, and the constraints of long-distance space travel, could become relics of a bygone era. With such abundant energy, we could terraform planets, power interstellar ships, and eliminate our dependence on fossil fuels forever. The Dyson sphere represents a potential turning point in human civilization, a leap from a species bound to its home planet to one wielding the energy output of a star. It's a vision of the future where humanity becomes a true spacefaring civilization, capable of shaping not just our world, but the cosmos itself. But such a monumental leap comes with equally monumental challenges. The engineering, logistics, and sheer scale of the project are almost beyond comprehension. It would require new materials, new technologies, and a level of cooperation never before seen in human history. How do you even begin to construct a structure so vast, so complex, in the harsh environment of space? The logistics of transporting materials, assembling components, and maintaining such a megastructure would push the limits of our ingenuity and perseverance. What materials could withstand the intense radiation and gravitational forces near the sun? We would need to invent entirely new classes of substances, capable of surviving conditions far more extreme than anything we've ever encountered. And what would it mean for humanity to possess this level of power? Would it unite us in a common purpose, or create new divisions and dangers? The ethical, social, and philosophical questions are as vast as the engineering ones. The journey to understanding the Dyson sphere begins with its conception in the mind of physicist and futurist Freeman Dyson. His vision continues to inspire us to dream bigger, to reach further, and to imagine a future where the full power of our star is finally within our grasp. The Dyson sphere, as the name suggests, did not spring from thin air. Its origins are rooted in a blend of scientific curiosity and bold imagination, a testament to humanity's relentless drive to understand and shape the universe. It was the brainchild of physicist and mathematician Freeman Dyson, a scientific visionary who dared to imagine the unimaginable. Dyson's ideas were not just ahead of his time, they challenged the very boundaries of what we thought possible in the cosmos. In 1960, Dyson published a paper titled Search for Artificial Stellar Sources of Infrared Radiation, which first introduced the concept to the world. This paper, though technical, sparked a wave of fascination and debate among scientists and science fiction writers alike. Intriguingly, Dyson himself didn't intend to propose a blueprint for an actual megastructure. Rather, He was exploring the possibility of detecting advanced extraterrestrial civilizations. His thought experiment was a way to expand our search for intelligent life beyond Earth. Dyson theorized that a sufficiently advanced civilization, facing ever-increasing energy demands, would eventually seek to harness the full power of its star. Such a civilization, he reasoned, would need to capture energy on a scale far beyond anything humanity had ever attempted. He envisioned a system of orbiting structures, perhaps a swarm of satellites or a network of rings surrounding a star and capturing its energy. These structures wouldn't necessarily form a solid shell, but could be a vast, dynamic array, constantly shifting and adapting. This energy, Dyson argued, would be re-radiated as infrared radiation, detectable across interstellar distances. The telltale signature of such a civilization would be a star that appeared dim in visible light, but glowed brightly in the infrared spectrum. By searching for these telltale signs of infrared, we might just find evidence of advanced alien life. The search for Dyson spheres has become a cornerstone of the scientific hunt for extraterrestrial intelligence, inspiring new methods and technologies. While the search for extraterrestrial Dyson spheres continues, the concept has taken on a life of its own. It has inspired countless works of science fiction and has become a symbol of ultimate technological achievement. Scientists and engineers have grappled with the immense challenges of actually building such a structure. The engineering hurdles are staggering. The materials, the energy required, and the logistics of construction on a solar scale are almost beyond comprehension. Could it be done? And if so, what would a Dyson sphere actually look like? The answers remain uncertain, but the idea continues to push the boundaries of our imagination, inviting us to dream bigger and reach further into the cosmos. When most people hear the term Dyson sphere, they often imagine a colossal solid shell completely surrounding the sun, a vast impenetrable barrier capturing every ray of sunlight. This vision has captured the imagination of science fiction writers and futurists for decades, painting a picture of ultimate technological achievement. However, while this image is visually stunning and awe-inspiring, the reality of building such a structure is fraught with almost insurmountable challenges. To construct a solid shell of this magnitude, we would need an unimaginable amount of raw material, far more than what exists in all the planets, moons, and asteroids of our solar system combined. The logistics of gathering, transporting, and assembling this material would be a project on a scale never before attempted by humanity. Beyond the sheer material requirements, a solid shell would be inherently unstable. It would be constantly threatened by gravitational forces which could cause catastrophic collapse, and by impacts from asteroids, comets, or even space debris. Any significant collision could compromise the entire structure, leading to disaster on a cosmic scale. Recognizing these obstacles, scientists and engineers have proposed a more practical alternative, the Dyson swarm. Instead of a single monolithic shell, a Dyson swarm consists of millions or even billions of smaller, independent structures like satellites or solar collectors orbiting the sun in a coordinated pattern. Each of these structures would be equipped to collect solar energy directly from the sun's rays and then beam that energy back to Earth, or perhaps to colonies and outposts scattered throughout the solar system. This approach allows for a flexible and distributed network of energy collectors. The modular nature of a Dyson swarm offers several key advantages over a solid shell. Not only does it make the system more resilient to damage, but it also allows for a wide variety of designs and technologies to be used, adapting to new discoveries and innovations as they arise. Perhaps most importantly, a Dyson swarm is scalable. We could begin with just a handful of satellites and gradually expand the network over decades or centuries, steadily increasing our ability to harvest solar energy as our needs and capabilities grow. If a single satellite malfunctions or is damaged, it can be repaired or replaced without threatening the integrity of the entire system. This decentralized approach greatly reduces the risk of catastrophic failure. The swarm can also be dynamically adjusted, with satellites repositioning themselves to maximize energy collection as the sun's output changes or as new technologies become available. Another intriguing concept is the Dyson ring. This idea envisions a single massive ring of solar collectors orbiting the sun, forming a continuous band at a fixed distance. Imagine a gigantic ring, perhaps at the same distance from the sun as Earth, capturing a substantial fraction of the sun's energy output and transmitting it to wherever it's needed. This ring, covered in advanced solar panels, could serve as a powerful energy source for Earth and future space settlements, beaming clean energy across vast distances. While a Dyson ring doesn't capture as much energy as a full sphere or a vast swarm, it represents a realistic and achievable first step, a stepping stone on humanity's journey to harnessing the full, almost limitless power of our sun.